Bonjour. Today we start on chapter 6 of Transmath 4. This chapter is called Comprendre la notation puissance. It is in English to understanding the notation of power, raising to a power. You already know this. I again remind you, this is what you should have finished last year. We're just doing the chapters you didn't do in detail last year. Okay, so this is one of the chapters in the book that is really not well explained. So I will give you a detailed explanation of the concepts, and then we will start as usual on the problems. The video will be in two parts. So today is the first part of the video. So chapitre 6, comprendre la notation puissance. Okay. So remember in the last chapter, which was on multiplication and division of fractions, I had mentioned somewhere multiplication is repeated addition. 5 into 4 is actually equal to 5 plus 5 plus 5 plus 5. 4 times you have to add 5. Correct? Yeah. Now, raising to a power, that is taking something to a power, prendre la puissance, raising to a power is just repeated multiplication. So if you have a number like 5 to the power 4, this is how you write it. 5 is written normally, 4 is written smaller and above there as a superscript. If you know these terms from word processing, it's written higher. 5 to the power 4 means 5 into 5 into 5 into 5. Here it was plus plus plus, here it's into into into. So this is just a shorthand method, concise method of writing this. Just as this is a concise method of writing this. So, and this number up here, 4, is called exposant en français and exponent in English. We will use these terms quite a lot. How do you read this? How do you read this? So in French you say 5 à la puissance 4. Ou 5 exposant 4. You always say this number first, and the number you're raising to the power of you say after. 5 exposant 4, 5 à la puissance 4. In English, there's many different ways of saying it. The long way is 5 raised to the 4th power. Sometimes even said 5 to the 4th. Or 5 to the 4th power, they drop out the raised, or this is rare, 5 exponent 4. So any one of these you can say to represent this. Now there are, so the general form is a la puissance n est égal à a fois a fois a fois a fois, as there are n numbers of a. This is the general thing where a is any number. It could be negative, it could be positive, it could even be 0. 0 to power anything is 0 into 0, that many number of times, which is actually 0. A to the power 1 is equal to a because you're just taking it once. So you see that I put a box around. These are important definitions. You should maybe copy them down on a separate piece of paper, so that later on when you do the problems you have a handy reference. Each one of these, as I go and give you, will be explained so you know how you arrive at that. For two terms, when you have 2 there and 3 there for these two terms, you have a special term. A fois a est égal à est lit comme a au carré or a square. A à la puissance 3 est égal à fois a est égal à, is read as a au cube or a cube or a cubed. So just for power of 2 and power of 3 you can use carré, square, cube, cubed. Otherwise you have to read it like this. Okay. Now we come to, suppose I have a fois a la puissance 3 fois a la puissance 2. What does it equal? It equals a fois a, that is this one, the first one, into a au carré, a fois a. I put the brackets just for clarity, but they're really not necessary because this is multiplication. I could have written without the brackets here. Just put the brackets to signify, to show that this term, that this term corresponds to this and this term corresponds to this. Now a into a into a into a into a into a 5 times is equal to a to the power 5. You can see a relationship here between 3 and 2 and 5. Yes, of course, 3 plus 2 is equal to 5. So we come to this result. A to the power m plus a to the power n is equal to a to the power m plus n. A to the power 3 plus a to the power 2 is equal to a to the power 3 plus 2, which is equal to a to the power 5. So this is a special thing. I have again put it in a rectangle in a box so that you remember this is an important result. For example, if we take 6 to the power 12 into 6 to the power 3, I don't have to do it on the calculator. I can straight away say this will be equal 6 to the power 15. Now remember, this is multiplication. What about addition? If I have 2 to the power 3 plus 2 to the power 4, what can I write? 2 to the power what? Actually, this is not possible to write like this, where this question mark is replaced by an integer. So 2 to the power 3 plus 2 to the power 4 is equal to 8. 2 to the power 3 is 8. 2 into 2 into 2 is 8. 2 to the power 4 is 16. 2 into 2 into 2 into 2 is 16. So 8 plus 16 gives us 24. 24 is not a power of 2. So I cannot put something here, an integer here, to represent this. So if you have a plus or a minus in between two terms which are raised to a power, you cannot simplify them in this manner. Don't ever get confused by this. Only if there's a multiplication sign can you do something like this. Okay. So now, what about if the numbers are the same? Numbers are different but the powers are the same. For example, here 9 squared plus 4 squared, I am taking both to the same power. What is it equal to? Can I write a to the power b anything? Again, it is not possible because 9 squared is 81, 4 squared is 16, that gives us 1296. 81 into 16 will give us 1296, and that is cannot be written in this form, which relates 9, 4 and 2. So this only works if these two numbers are the same, a is the same on both terms, and you have a multiplication sign in between. Then you can say a to the power b plus c. Okay. Now remember, we come back to Padma's. P stands for power. P stands for parenthesis, O stands for order. Order is what we call power here. So if you have 2a cube like this, it means 2 into a cube. That means you take the a cube first and then multiply by 2. This is not equal to 2a, whole of that cubed. Remember, whenever you see this term, first you have to do the power, then you have to do the multiplication into 2. It is not equal to this. If you want to do this, you have to see, for example, we'll take 2 into a to the power 3, we can write, if we take a is 6, 2 into 6 to the power 3 is 2 into 216. 216 is actually 6 into 6 into 6, which gives us 432. This is not equal to 2 into 6 to the power 3, which is 12 to the power 3. 12 to the power 3 is not 432. Okay. So always remember, when you have this, first you do the power, then you do the multiplication. What if you have powers of power? So it's not a very mathematical way of saying writing it, but what do you have powers of power? See, if you have a to the power m, the whole thing raised to the power n, what does this equal? This is interesting. So let's take, we have 2 to the power 2 raised to the power 3. So the first thing we do is 2 to the power 2. So we take 2 into 2. But that we have to multiply 3 times by itself. So we have 2 into 2 into 2 into 2 into 2 into 2. What is this equal to? This is very simply equal to 2 to the power 6. So do you see a relationship between this 6 and 2 and 3? Yes, 2 into 3 is equal to 6. So we come to the rule a to the power m, the whole thing raised to the power n is equal to a into m into n. Remember, this is into here. What we had in the previous page was plus. If you have just if you have a to the power m into a to the power n, it is a to the power m plus n. But here a to the power m to the power n is equal to a to the power m into n. And now we can also see a to the power m to the power n is equal to a to the power n to the power m, because both of these are equal to a to the power m into n. M into n is equal to n into m. So either way, if you write it like this, so that means something like this: 2 to the power 3 to the power 6 is equal to 2 to the power 6 to the power 3, because 3 into 6 is equal to 6 into 3. Okay, so now that we have done so far, let's do 5 in video problems. You have to write 6 to the power 3 plus 6 to the power 2 is equal to 6 to the power what? This one you have to, so all of these you have to simplify. You don't really have to give me the actual calculated answer. This is 23 to the power 2 into 23 to the power 1. What will it be? You have to simplify it. You don't have to actually calculate it. 16 to the power 4, the whole thing to the power 2. What will this equal? Again you simplify. 6 to the power 3 plus 6 to the power 3 is equal to 6 to the power 3 into what? See if you can find out something that fits here. And 6a into 6a to the power 5. Can you simplify this? So try and see how this is done. For this, remember this rule here. Here, the Podmas rule for powers and multiplication. Okay. Now let's come to division. So what do we have if I have a to the power m divided by a to the power n? Can we simplify this in any way? Let's say we have 6 to the power 12 divided by 6 to the power 3. Can we simplify this? So let's see, what can we get? So let's take an example, 2 to the power 6 divided by 2 to the power 4. So 2 to the power 6 is, remember, we don't do, this is again Podmas. So first you do the powers, both the powers, and then you do the division. So you do 2 into 2 into 2 into 2 into 2, 6 2's, and here you have 2 into 2 into 2 into 2, 4 2's. So what do you get? All these 4 will get cancelled out with the first 4. You'll get 2 into 2. You'll get 2 to the power 2. What does it mean? Let's take another example. 5 to the power 4 divided by 5. What is 5? 5 is the same as 5 to the power 1. So you get 5 into 5 into 5 into 5 divided by 5. 1 5 will get cancelled on the top. You'll get 5 to the power 3. So this leads us to this rule. A to the power m divided by a to the power n is equal to a to the power m minus n. It's the opposite of the multiplication, where a to the power m into a to the power n was equal to a to the power m plus n. Here a to the power m divided by a to the power n is equal to a to the power m minus n. Remember, a cannot be 0 because division by 0 is not defined. So for example, if I have t to the power 17 divided by t to the power 12, I can immediately say this is t to the power 5. Why 5? Because it is 17 minus 12. 17 minus 12. Okay. What is a to the power m divided by a to the power m? The same thing, where a of course is not equal to 0. This I have to say whenever I am putting a below, whenever I am dividing by a. Here also t cannot be 0. So what is this? Well, we'll use this rule. So we'll get a to the power m minus m, which is 0. So a to the power m over a to the power m is equal to a to the power m minus m, which is equal to a to the power 0. Now remember, a to the power 1 is 1, but a to the power 0 is what? What does this mean? We also know that a to the power m divided by a to the power m is equal to, this is something divided by the same thing is equal to, anything divided by anything is equal to 1. But a to the power m divided by a to the power m is equal to 1. So, but a to the power m divided by a to the power m by this rule is equal to a to the power 0. So a to the power 0 is equal to 1. So therefore we come to a funny definition. A to the power 0 is equal to 1. And this 1 is independent of the value of a. So you could take any number here and you'll still get 1. So if you take 16 to the power 0, it is 1. If you take minus 353.789 to the power 0, it's still equal to 1. Don't spend too much time trying to figure this out, but you are likely to, what should I say, this don't try to think what a to the power 0 means, just figure it in terms of consistency with this equation. So if I say it in English, any non-zero number raised to the 0th power equals 1. This is true. Any non-zero number raised to the 0th power equals 1. Except that is non-zero number. 0 to the power 0 is undefined, because 0 into anything should be 0, but we have also said here anything to the power 0 is 1. So 0 to the power 0 is undefined, but anything else to the power 0 is equal to 1. Negative number, positive number, fractional number, rational number, irrational number. Okay. So now we come to, I give you 4 more problems. 16 to the power 25 divided by 16 to the power 24. Again, all of these you have to simplify. You don't have to actually plug them into your calculator and give me the number. That's all. Only 16. 16 to the power 0 is equal to how much? 16 to the power 24 divided by 16 to the power 25 is equal to how much? These are all applications of this rule. And here, slightly more complicated. Here you have to think about Padmas also. 2 to the power, sorry, not 2 to the power, 2 into s to the power 16 divided by 3 into s to the power 14 is equal to how much? This also you have to simplify. You don't really have to calculate it. You can't calculate it because you don't know the value of s here. Okay. So, now I've been talking for about 19 minutes and I'm going to stop here because there are 2 or 3 more topics to cover for notation of power in this chapter, but I'll do that tomorrow in a separate video which will be slightly shorter than this. I would suggest that wherever I've got boxed results, you copy them separately on a bit of paper that you can refer to conveniently. And I spoke quite fast as I tend to do, so you might like to go back and watch separate parts of this video again. You can even watch again, as I remind you, in YouTube you can actually slow down the video without distorting my voice too much, and you can watch it at a slower speed than normal. Okay, I stop here. These A, B, C, D, E, F, G, H, I, these 9 in video problems you have to submit to me.